Hello everyone, I'm Aihca, PhD candidate and member of Thermodynamics and Energetics Laboratory, Faculty of Science of Agadir. I'm very pleased to be here with you today to present one of the studies that will make a huge contribution to the field of energy efficiency in construction and building materials. My presentation is entitled Thermal Conductivity of Clay-Based Material Incorporating Argan Shell. The building sector is considered one of the most energy-intensive sectors in the world. In Morocco, the building sector represents 25% of the country's total energy consumption. Within this framework, the AMI has launched an energy efficiency program in the building industry. This program had led to the thermal regulation of construction in Morocco, Lahcen 2015, and the main objective is to reduce energy consumption in the sector. In this sense, scientific research seeks to propose solutions for an energy transition towards renewable and ecological resources. The objective of this study is to use locally available natural, recyclable and environmentally friendly materials as components of building materials in order to improve the comfort of the building environment. The use of natural material does not only meet the requirements of the RTCM by reducing energy consumption, but also meets the challenges of sustainable development. In the present study, new composites based on local materials are evaluated experimentally in order to obtain environmentally friendly materials with low manufacturing costs and the best thermophysical properties. They are mainly fired clay bricks incorporating biomass waste additives. In our first phase, I present to you the materials and additives chosen to make the samples. The materials used for our samples are materials that are abundant in the Souss Massa region. The red clay is presented as a material with high thermal performance. Unlike most building materials, clay can be used in its natural state. The clay was extracted from a red clay quarry. The identification tests that we carried out on the soil samples are the particle size analysis by sieving and by sedimentation. For the mineralogical characterization of the clay samples, we used an X-ray diffractometer. The powder of argan shell used is obtained by grinding using a knife mill, then sieved between 1 and 0.5 mm diameter sieves. Moving on to sample preparation. We have made the brick samples by varying the percentage of additive and red clay. The samples were mixed until homogeneity with the minimal amount of water to get the right plastic consistency, then molded. The samples are dried at room temperature 48 hours, then at 105 degrees for 24 hours, until constant mass is reached. The bricks were baked in an electric oven up to 1050 degrees Celsius. The samples are cooled to room temperature inside the oven by natural convection. We will focus today on presenting thermophysical results of the samples incorporating 0, 50 and 20% of argan shell. The bulk density and the porosity percentage of the samples are measured. The thermal conductivity was determined using a hard disk TPS 5000 analyzer. Now we will move on to the presentation of results. The clay sample is identified as sandy clay. According to the analyzers, 12% by weight is presented by clay and 53% by sand. This result is consistent with the X-ray diffraction data. Quartz, electrolytes, and calcite are the main crystalline phases of the sample. The physical properties of the sample's composite show that incorporating biomass additives in fired clay bricks reduces the bulk density to 42% and increases the porosity by 32% using 20% by weight of biomass additive. The thermal conductivity of the bricks is presented in the figure. The results show that the bricks with biomass additive reach a conductivity of 0.27. The thermal conductivity is reduced by 39 and 53% using 50 and 20% by weight of biomass additive. The decrease of the thermal conductivity is associated to the formation of pores. In fact, the thermal conductivity decreases because of the low thermal conductivity of air in the newly formed pores. The aim of the study is to use locally available materials as building material in order to improve the energy efficiency of buildings by reducing thermal conductivity and improving physical properties such as back density. The clay samples show that the thermal conductivity decreased with the increase in the percentage of additives, and this is due mainly to the formation of air pores in the bricks. The use of composite clay and organic additives can revolutionize the building industry by allowing significant savings. Thank you.